Okay, in previous class we have done five important problem which has been given in Calcutta University graduation examination, and today we'll continue the next five problem, and this is basically previous year problem and we'll solve it with explanation. So now we'll start from question number 6. So here the question is state true and false. State true or false with justification, or false with justification if Z star be the set of all non-negative integers, be the set of all non-negative integers, and F is a mapping from Z to Z star is defined by Fx equals to half of x plus mod x for all x belongs to Z. Then Fx is a bijective mapping. Fx is a bijective mapping, that means the mapping is injective as well as surjective. Bijective mapping. And that question is given for 2 marks, and this is given in Calcutta Honors, B.Sc Honors Mathematics, the year of 2004. So now the thing is how to solve this kind of questions. So for bijective map, here first we recall some basic facts. Recall a map if A to B is called bijective, if and only if it is injective as well as surjective. This is recall 1. And recall 2, how you will show injectiveness. The map if A to B, this is called injective map if and only if Fx equals to Fy, that implies x equals to y for all xy belongs to A. And next recall, so for not injective, if there exists x, y belongs to A, be such that the image are basically same, Fx equals to Fy, but x not equals to y, then we call F is not injective. F is not injective on A. And if we talk about the surjectiveness, so F is a map A to B is called surjective, or onto map if and only if F of A equals to B. That means every element in the codomain set must have a P image in the domain set. But now how we will solve this question? So what is exactly given? Here it is given Z star. This is basically set of all non-negative integers. So that means it will be 0, 1, 2, 3, 4 and so on. And it is also given F is a map from Z to Z star that map is defined by f of x equals to half x plus mod x for all x belongs to Z. Now just we check here. Say this is your Z and this is your Z star. Z means 0, 1, 2, 3, 4 and so on. Minus 1, minus 2, minus 3. And Z star means 0, 1, 2, 3, 4. Set of all non-negative integers. Now if we take the image of the point 1, so 1, that will be 1 plus mod 1 by 2, and it goes, first we'll start from 0. So here the map of 0 is basically 0 because 0 plus mod 0 by 2. And for 1, 1 plus mod 1 by 2. So this is basically 1 plus 1, 2 by 2, that means 1. If we take minus 1, so minus 1 plus mod of minus 1, again minus 1 goes to 0. That means 0 and minus 1 goes to the same element, but 0 and minus 1 not same. So obviously this map is not injective. So what we have seen, we see that what is f of 0? F of 0 is basically 0 plus mod 0 by 2, and this is 0. And what is f of minus 1? That will be minus 1 plus mod of minus 1 by 2, again it is 0. So thus, therefore, f of 0 equals to f of minus 1 equals to 0, but 0 not equals to minus 1. Okay, and hence we conclude that if Z to Z star is not injective, because here Z to Z star, so it is 0, 1, 2, 3, 4 and so on. So here we have seen 0 goes to 0 and also minus 1, this element goes to 0. So two different and distinct elements, the image is basically same. So that means the map is not injective. And if a map is not injective, so that means, and hence we conclude it is not bijective. And hence we conclude that if Z to Z star is not a bijective map. Because bijective map implies it is injective as well as surjective. So not injective, that implies not bijective, or not surjective implies not bijective. So now we come to the next important question, question number 7. So here question is basically asked in the year of 2005, Calcutta University. So here question state, okay, here the question state true or false. So our answer is here, statement is false, and this is the justification. And here we have done the justification. Okay. Now here same kind of question has been asked. State true or false. False with justification. With justification. The map if R2 minus 1 1 open interval defined by f of x equals to x by 1 plus x square. What is x? Where x belongs to real number, that map is a bijective map. And this is also a 2 marks question. Okay, so you need to check it is bijective or not. So again we will see the statement is false, but we need the justification. So if we think about the answer, the statement is false because this map is not bijective. Okay. So statement is false. Now question is why the statement is false. You need to justify. So what we will do, we will justify. So that means we come to the point justification. The statement is false. That means here f is not bijective. So here the map f R2 minus 1 1 is defined by what is your fx? Fx equals to x by 1 plus x square where x belongs to R. Okay. Since f is okay, our first claim is what we have to show. We have to show if R2 minus 1 1, that map is not surjective. Is not surjective. That we have to show. That means we will consider an element on the codomain set and that element has no preimage. So as for example, so this is your set of real number. This is your codomain, say minus 1 to 1. Okay. So just think about minus 1 to 1. If we take a number, say 3 by 4, and we will say that element have no preimage. Why? Say let us consider an element, let 3 by 4 belongs to minus 1 1, and this is basically our codomain. And we will show that the element 3 by 4 has no preimage. If possible, let x belongs to R, that means domain, be a preimage of 3 by 4, and that is basically belongs to minus 1 1 codomain set. So just we consider, okay, x is a preimage. Now we'll see what will happen. So then obviously it will happen, since it is a preimage, so fx equals to 3 by 4. Now what is fx? Fx is basically x by 1 plus x square. That will be 3 by 4. And this implies 4x minus 3 minus 3x square, that will be 0. That means 3x square minus 4x plus 3 equals to 0. Now what will be the roots of the equation? So x will be minus b, 4 plus minus b square, 6 minus 4c, 4 into 3 into 3 by 2a. That means x is basically 4 plus minus root under minus 20, because root 12, 3 into 12, 36. So minus 20 by 6. So discriminant is negative, so it is basically does not belongs to R. So that means therefore the preimage of 3 by 4 is basically not a real number. So that means there does not exist any x belongs to R, which is a contradiction. As we said, x is a real number as x belongs to R, and here we have seen x is not a real number. So therefore we conclude there does not exist any real number such that fx equals to 3 by 4. So, and hence we prove that if R to open interval minus 1 1 is not surjective. Since it is not surjective, so we conclude here if R2 minus 1 1, that interval, this map is not bijective. In previous problem, f is not injective, that's why f is not bijective. On the next problem, f is not surjective, and that implies f is not bijective, because bijective implies both surjective and injectiveness. Now we come to next important problem. Problem number 8. And this question is asked in Calcutta University Honors, the year of 2002. 2002. What was the question? State true or false? State true or false with justification. With justification. A statement, the mapping if Z to Z, but Z is set of all integer, this is basically set of all integers defined by f of x equals to x plus 2. X plus 2 is not surjective. Not surjective. This is also for 2 marks question. And here the solution. Here we will see again the statement is false. The given statement is false because it is a surjective map. Is false. Why it is false? That we need justification. We need justification. Okay, so actually we have to show that if is map Z to Z, that map is surjective. If we show that, in that case we can prove, okay, this map is surjective. So we have set of integers to integers, so that means 0, 1, minus 1 to minus 2. Z to, we have another map, codomain is Z. So here map is x goes to x plus 2. Okay, so that will be 0, 1, 2, minus 1, minus 2, minus 3. So just to think, if we take the image of 0, so it will be 0 plus 2. So that means 0 goes to 2 and 1 goes to 3. Okay, because here x goes to x plus 2. Okay, so here f is defined Z to Z by f of x equals to x plus 2 for all x belongs to Z. Now just we take an pre-image, we take an element in the codomain set y, and we will say y has a pre-image in the domain set. So let y belongs to Z, and this is basically codomain. Then we have to show that exists pre-image. So choose x equals to y minus 2. Okay, since y belongs to Z, so that is also belongs to Z, and this is a domain set. Since y is integer, so y minus 2 must be an integer, so x belongs to Z. So now what will be the f of x? So f of x, it will be f of y minus 2, and what is the map f of that will be y minus 2 plus 2. Y. So therefore, what we have seen, y minus 2 equals to y. So for all y belongs to Z. Therefore, y has a pre-image y minus 2 in the domain set. Domain set Z. Thus we conclude every element in the codomain set Z, must have a pre-image in the domain set Z. the domain set Z, that means domain, and hence we conclude if Z to Z is a surjective map. So what is exactly given in question paper? This is not surjective, that means it's a false statement that is justified. Now what we will do when we first recall about inverse. So when F inverse exists, when our question is when F inverse exists, where F is a function from A to B. Okay, so our simple answer is if F is a bijective mapping. So our answer is if F is bijective mapping, if A to B, that map is bijective, and so we can say F is invertible, and hence F inverse, this will be B to A, that will exist. Okay, and there is another important concept. The concept is left inverse. When left inverse exists, or the definition is let if is a map from A to B, be any function, so a function G, this is basically B to A, is called left inverse of F if G of Fa, this is equals to A for all A belongs to A. That is, if G composed F is basically identity, this is identity map on A. Okay, why? Because G composed F of A equals to A for all A belongs to A, and that implies that is basically G composed F equals to identity map on A. And if we define the right inverse, now we come to the definition of right inverse. So let F is a map from A to B, be any function. So this is A and this is B, map is F. So another map we deduce here G. So G will be right inverse of function GB to A is called right inverse of F if F of GA, this is equals to A for all A belongs to B. Okay, that is if F compose G of A, this is equals to A for all A belongs to B. That is if F compose G equals to identity map on B. This is basically definition of right inverse. Okay, so now we'll come to the question The question is, okay, before that we come to some important theorem, and you can call it as the recall. Let if a to b be any function with a left inverse, be any function with a left inverse, then if a to b must be injective, function. Okay, and that is another theorem. Let if a to b be a function with right inverse, be a function with right inverse, then we must have this result if a to b must be surjective, function. Okay, so now we'll come to the next important problem. The problem is so this is basically problem number 9, and this problem is asked in the year of Calcutta University in the year of 2010. So question is this is 2C2. The question is a function if z to z is defined by f of x equals to x by 2. So x by 2 if x is even, and if 7 if x is odd, integer. And the question, it has been asked, find a left inverse of a, f if it exists. So this is basically 2 marks question. So for left inverse, what we have seen here, f must be injective map. If a to b, that function has left inverse, so that means if a to b must be injective map. So first we will check this map is injective or not. So what is map here? The map is, say, 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, and so on. Again 0, 1, 2, 3, 4, 5, so on, minus 1, minus 2, minus 3, and so on. So if we think about the element of the map 0, 0 is an even number, so 0 by 2, so that means 0 goes to 0. 1 is odd, so that means 1 goes to 5, 6, 7. So that means 1 goes to 7. And again, if we take 3, so 3 also goes to 7. 5 is also goes to 7. So this map is not injective. So hence we can say not injective, that means it has no left inverse. Okay. So the simple logic is our solution is the function is not 1, 1. The function if z to z is not injective. Why? Because since f of 1 equals to f of 3 equals to 7, but 1 not equals to 3 by the definition of map. because 1 and 7 are odd number. So here we observe, we see that f of 1 equals to f of 3 equals to f of 5 equals to f of 7. So f of 2n plus 1, that number is basically 7. So that means we conclude here f is not injective because f of 1 equals to f of 3 7, but 1 not equals to 3. And since it is not injective, so the left inverse is not exist. Because if left inverse exists, then it must be injective function. Since if Z to Z is not injective, so we conclude that the left inverse of f does not exist. So this information is sufficient. Why the left inverse does not exist? If exists, then obviously we will show the left inverse. Okay. So now we'll come to next important problem. So what is the problem? They find the next question, question number 10. And this question also asked in Calcutta Honors Examination for mathematics paper. They find bijective mapping, find all bijective mapping, find all bijective mapping from the set A, onto itself. Where what is the set A? The A set is 1, 2, 3. Okay, and this question is asked basically 1998, and this is 3 marks question. But before solving the question, we must have to know some recall. Our recall some basic facts. Our fact is recall some basic facts. So our fact is if A to A is called bijective, if and only if it is injective as well as surjective. So this is our fact 1. Our fact 2, basically number of bijective mapping, F from A to A, where cardinality of A equals to n, this is basically finite number, is equals to n factorial. So by using the fact, since our A is basically 1, 2, 3, so cardinality of A is 3, and F is a map from A to A, so number of bijective mapping F from A to A, this will be is equals to 3 factorial, that means 6. So there are 6 bijective mapping. We need to decide all those maps. So therefore what we conclude? We conclude there are exactly factorial 3, that means 6 bijective mapping, 6 bijective mapping from A to A. From A to A. And now we'll think about what are the bijective mappings. A to A. So the first map, if A to A, this is bijective, so that we can draw in that way. This map is identity map. So 1 goes to 1, 2 goes to 2, and 3 goes to 3. So here the first map is f of x goes to f of 1 equals to 1, f of 2 equals to 2, f of 3 equals to 3. Okay? Or we can write in that way: 1 goes to 1, 2 goes to 2, and 3 goes to 3. Now the second bijective map, if that we consider, okay, the second, if A to A, this is A and this is also A. So 1, 2, 3, 1, 2, 3. So 1 goes to 2, 2 goes to 3, and 3 goes to 1. So 1 goes to 2, 2 goes to 3, and 3 goes to 1. This is the second bijective mapping. The third bijective mapping, again, if A to A, 1, 2, 3, 1, 2, 3, 1 goes to 3, and 2 goes to 1, and 3 goes to 2. So 1 goes to 3, 2 goes to 1, and f of 3, 3 goes to 2. This is the third bijective map. You can easily check it is a bijective map because every element has a pre-image and distinct element. The image of distinct element is also distinct. Now the fourth bijective map, again, if A to B, A to A. So this is your A, this is your B, sorry, A. 1, 2, 3, 1, 2, 3. So 1 goes to 1, and just 2 and 3 they alternate. So f of 1 is 1, but f of 2 is 3, and f of 3 is 2. So this is fourth bijective mapping. Now we goes to the 5, if into fifth bijective map. So 1, 2, 3, 1, 2, 3, A and A. 2 goes to 2, 3 goes to 1, and 1 goes to 3. So f of 1, 3, f of 2 is 2, and f of 3 is 1. Now we come to the sixth. If A to A, so this is A and this is your B. 1, 2, 3, 1, 2, 3. So 3 goes to 3. Now interchange these two. That means f of 1 goes to 2, f of 2 goes to 1, and f of 3 goes to 3. So these are the 6 bijective mapping from the set A to the set A again itself. Thank you so much. In the next class again we will do 5 important previous year problem, which is set up by Calcutta University for Mathematics B.Sc Honors. Thank you so much.